class, welcome to Lesson 4 on Scientific Notation and Significant Figures. By the end of this lesson, you should be able to use scientific notation to report numbers from measurements and calculations to the proper number of significant digits and convert numbers between scientific notation and standard notation. Make sure you're taking notes. I recommend the guided notes you'll find on Google Classroom. Have a scientific non-graphing calculator, and let's get started. This hopefully is a review, but if it's not, it's okay. We'll talk about it. So scientific notation is a way in which we can express very large and very small numbers. And all numbers in scientific notation include a coefficient or a value between 1 and 10. It can be a decimal, and then it will be multiplied by 10 to an exponent. Now, when the exponent is negative, that indicates that the number is very small, so the number is less than 1. And when the exponent is positive, it indicates a very large number or a larger number, a number larger than 1. Notice the millimeter distance between two hydrogen atoms in a hydrogen gas molecule. You can see it's a very small value. But instead of writing all those zeros, which can be really hard to transfer from one place to another, we can rewrite this number in scientific notation. So in scientific notation, we would move our decimal so it results in a number between 1 and 10. So 3.70 times 10 to the negative 8. Now, why is it a negative 8? Because the original value is much smaller than the value of 1. Now, when we think about the number of water molecules in just 1 milliliter of water, so a teaspoon is about 5 milliliters. So in 1 milliliter of water, we have lots of water molecules. But this number, since it's really big, its exponent's going to be a positive number, and it can be written as 3.34 times 10 to the 19th power. So the basic way in which we write numbers in scientific notation directly connects with significant digits, because we know that many times zeros, whether they come in the front of a number or in the back of a number, are not significant. So basically, scientific notation, all of the numbers that are in the coefficient that come before the times 10 to a power, all of those digits are the only significant digits of the value. And so it's the significant digits times 10 to the number of places you have to move the decimal point.
So let's try and write these two values to 3 significant digits in scientific notation. The first thing I'm going to do is round each value to 3 significant digits. Here, when I want to go and have the first 3 significant digits, I'm going to underline the first 3 digits and circle the fourth. So this is going to round by staying, and then all of the rest of the digits need to be written as placeholders, because we want to show how big the number is, but we don't want to add any more significant digits. Now for this value, we're going to circle the first 3 digits and look at the fourth for rounding. And so that's 3, 4, and then this 7 makes that 4 round up. Now, the important thing though is we have to put in these insignificant zeros to show place value. In chemistry, we do not typically write commas in large numbers, but we do put a break every 3. And we also tend to put a break every 3 in decimal places, just to help you very quickly see the magnitude of the number. Now let's write these in scientific notation. So you want to find the decimal. So this is a very large number. The decimal would belong here. We don't write it because we don't want to make these zeros significant. But you slide the decimal. So in this case, we're going to slide to the left because we're on the very right of the number. We're going to slide the decimal until we can get a value between 1 and 10. So the value between 1 and 10 would be 7.89. And then we have to count how many places we moved our decimal. So we moved it 3, 6, 9, 10, 11. So that's times 10, and the exponent is 11, and it's going to be a positive 11 because my number is greater than 1. Now in this example, we're going to do the same thing, but our decimal is to the left of the number, so we're going to move it to the right until we get a number between 1 and 10. So as I move it over, I'm going to have to put it 3.45 and then times 10, and now I need to count how many spaces I moved it. 3, 4, 5. So this is to the 5th power, but since this number is less than 1, it's a small number, its exponent is negative.
When you have a calculator like this, you can use the calculator to easily switch between standard mode and scientific notation mode. So what you'll want to do is just hit second and the degree button, and you can switch between the two. So when we put numbers in scientific notation in our calculator, it can become redundant to do times 10 and an exponent, especially because sometimes that may make you a power of 10 off. It's just a common mathematical error. So it is suggested that you use the power of 10 button, which on this standard calculator is the double E key. And on other calculators, it might be EXP. So you'll have to hit second and the double E.
Here, you are asked to write the numbers in standard form. The easiest way to do this is to put the number in your calculator. So if you have a calculator like mine, it has a special times 10 to the power button. So I would put this number in by typing 6.10, and then for times 10, I'm not going to go and use times 10 in an exponent, but instead I'm going to hit this second button and this double E key. Some calculators, it's written as double E. Some other calculators will have a button down here and it'll say EXP. Now that means times 10 to the. So it's important we understand calculator language, but we always write our numbers as numbers, so your answer will never have an E in it. So so this is times 10 to the second power. So after the E, we're just going to hit 2 and enter. And this gives us the value of 610. So let's do this 2 more times together, and you can do the last 2 on your own. So for this value, we're going to put in 3.8, second, E, and then we're going to put in a 4. And so here you can see our value is 38,000. Now remember, no commas in your numbers in chemistry, but you can place a space where a comma should go. Now let's try a negative number. Same idea. And now we're going to hit enter. And so this value is, you try these two and place your answer in Google Classroom. Remember, absolutely no commas. You may place a space between digits, or you can place all the digits together. You choose. Here, you are asked to convert these values to scientific notation. And although I'm confident you now know how to find the decimal place, make a coefficient between 1 and 10, and raise the power of 10 to the number of places you've moved the decimal place, let me show you a shortcut with your calculator. So particularly if you have this calculator, if you have another calculator, you can always go to tutoring, and a chemistry teacher will help you in the library figure out how to do this on your calculator. But what you want to do is you want to change your calculator from standard decimal mode into scientific notation mode. And on this calculator, to do that, you're going to hit second and degree, and then you're going to go and select science and enter. And so all we're going to do is we're going to put in this value, 900, and hit enter. And you can see that it tells us this is 9 times 10 to the second power. Again, we can repeat, we can put in the next number and hit equals, and notice how it gives us this. You can see that they don't write power of 10 very large here. Your calculator might even write it with a capital E. Make sure that you don't write the number with a capital E, but instead you write the number with an exponent for your 10. You try the next two examples. Make sure that you understand that these numbers are continuous. The space just helps you see every 3 place values, and you can put your answer on Google Classroom.
By now, you should be able to convert between scientific notation and standard notation. When we look at these two rulers, you can see an example where scientific notation may be necessary to report measured values to the correct number of significant digits. So both of these rulers are measuring the same length, and the length here appears to be about 140 centimeters. The thing is that when we say 140 for the first ruler, we mean that we are estimating the ones place to be a 0. Versus when we say 140 on the lower ruler, we mean that the tens place is estimated to be at approximately 40. So for the first ruler, we can simply write it as 140, which is 3 significant digits. But in the second ruler, we want to only write it with 2 significant digits. So we have 2 options here. The first option is, for the first ruler, what we can do is to write it to 3 significant digits. We can include the decimal point after the 140, or we can write it in scientific notation. All the numbers of the coefficient are the significant numbers. So 1.40 has 3 significant digits. Now, for the next measurement, we can either write it as 140 with no decimal point, making that 0 insignificant. Or more clearly, we can write it in scientific notation as 1.4 times 10 to the second power. So although mathematically they have the same quantity, in science they have different meanings because they convey a different amount of precision on each instrument. So by now you should be able to use scientific notation to accurately reflect the significant digits in a measurement. Congratulations, you've reached the end of lesson 4. By now you should have taken good notes. If you didn't, go back and take good notes. Complete your homework on Google Classroom and bring any questions you have to class. I'll see you soon.